Alright, ladies and gentlemen, let's go ahead and get started with our video for today. And I actually had some really kind of cool demonstrations to show you using the Inspire software. And this is looking at parallel lines and proportional parts. This is actually a really useful tool that you can use, and a lot of surveyors actually use this concept when they're trying to figure out different lengths of objects, especially open water. This really helps them figure those types of things out. What you see here is that you have line AB, CD, and EF, and all three of those lines are parallel. And then you have the two transversals AE and BF that are intersecting those three lines. What I want you to notice is that up here, if I have three or more parallel lines cut by two transversals, we actually have a very interesting outcome from this. And so what I want you to notice is if you look at AC is clearly not the same length as BD, nor is it the same length as CE or DF. So this is actually going to work for any general case. But what's kind of neat here is I want you to look at the ratios over here on the right hand side. If you look at the ratio of AC to CE and the ratio of BD to DF, what do you notice about the ratios? In our case at this moment, they're the same. What's interesting is that no matter where I put CD, what do you notice about those ratios? Again, it's the same. In fact, wherever I put EF, it's also the same. And in fact, if I put AB way down here, again, it stays the same. So the concept to take out of this short little video is that if the ratios are the same, that means that they are proportional. So we have this major theorem in geometry that says that if three or more parallel lines are cut by two transversals, then those parallel lines cut the transversals into proportional parts. And I didn't really show you this ratio, but you could have also have done the ratio of CE to DF and the ratio of A. Actually, let's go ahead and do that. So I'm going to go ahead and put in a new text. I'm going to go, let's do some quick edits here. So we're going to go CD, oh, not CD, sorry, CE to DF equals, okay. And then I'm going to create a new text box. I'm going to call that X over Y. Okay, and then I'm going to go ahead and calculate this. Alright, and then for X, so I'll put that up here. Alright, so then for X, so that was CE to DF. So we get this ratio. And then if we do AE over BF, and I guess that's actually not going to put it into a fraction, so let's go ahead and do that ourselves. So we get AE over BF, and then for this one, let's do E over F. And let's calculate. I'm not ready to calculate that. Oh, yeah, we'll go AC to BD. Sorry, guys. That's but basically, what I want you guys to notice. So you have two things here. So whether I'm on the same side right up here, these two ratios are based on AC and CE. So them being on the same side of the, being on the same transversal. The same concept works even if you're on opposite transversals. So notice the ratio of AC to BD and the ratio of CE to DF. Again, those are going to be proportional. So again, basically what you need to remember is that it cuts this stuff into proportional parts. Okay, the last thing I want to point out to you, which is really, really kind of neat, take a look at your notebook paper. And on your notebook paper, you will see that the blue lines are equidistant from one another. They're equally spaced. If you look at that red line right down the margin, and you really look at it, you'll see that the length of the red line between each of the blue lines is the same. No matter what two blue lines you're looking at, it's always the same. In fact, if you were to take a transversal, take a ruler and draw a line diagonally across the page, no matter at what angle, you would end up with a very interesting result. And that's what I'm about ready to show you right now. Okay, that's about as close as we can get. You can see we're fairly close here. The AC is equal to CE. What do you notice about BD and DF? When AC and CE are the same, what do you notice about BD and DF? They're also the same. So this brings us into the other concept of tomorrow's lesson, and that if the parallel lines are equally spaced, then it cuts the transversals into congruent segments. Okay? So that's just the two things I really want you to know for tomorrow. Parallel lines cut transversals into proportional parts, and if the parallel lines are equally spaced, it cuts the transversal into congruent parts. Okay? So that's pretty much all I want you guys to know for tomorrow, so hopefully you guys got that down. I would definitely make a couple of models, draw some diagrams based on this, and thank you guys for listening.